Hey everyone, happy Monday. Today's June 9th and we're working on Tim Turner's 4L80E. So got the valve body all assembled. This is the brains of the transmission. We fitted it with a CK Performance Master recalibration kit. We're running a block off plate in lieu of the third and fourth accumulator, which is what you want to do for all high performance type applications. And we've calibrated it for a street strip type use case. We've also installed all new solenoids, new EPC, PWM solenoid, shift solenoids A and B. If you guys watch my YouTube videos, you know I constantly harp on the need to replace solenoids and other electronic components at all times during overhaul. Don't ever reuse that stuff. So I know I sound like a broken record, but it's critically important to mitigate risk associated with bad electricals or electronics. And so you don't want the job coming back to you because of something like that. All right, so let's go to the bench and we'll kind of take a walk through the build, discuss all the parts and components, including upgrades. And for those of you that are watching, thinking about maybe building a 4L80E for the first time, I'll provide some tips and pointers along the way. So first things first, here on the right side of the bench, and then we'll work our way to the left, you see a very large aftermarket deep aluminum pan. This is a B&M pan. These are by far my favorite pans. I have them on my vehicles. I have automatic transmissions, and if there's room in your budget, I recommend you install one yourself. So the B&M pan allows for easy, efficient servicing via a drain plug, adds about 3.5 quarts, something like that. And it also has a provision for installing a mechanical or electromechanical sensor, such as a temperature switch or something like that, on the side of the pan. And I know you can't see it, but trust me, it's there. All right, in the pan, we have some more electrical components, brand new, a roster wiring harness. This is a 2003 unit. It's going into a 2005 Silverado. We used to have a 4L60E. It's now going to have a 4L80E and a 6-liter that's going to be making somewhere near 800 horsepower. So just for a little context. This is a manual lever position sensor. This is a late style, so 04 and up, because he has an 05. So I want to match connector with connector, but if we need to swap it out for the earlier style, we certainly can. Depends on what his vehicle wiring harness is provisioned for. Pressure switch manifold, OEM GM, and then going back to the pan, B&M will provide you a bag of hardware as well as a filter pickup seal and an extension tube. So if you buy these pans in the on the secondary market, like Marketplace or Craigslist or something like that, and it does not have the filter pickup extension tube, Summit, Jegs, and several other places sell them individually for about 15 to 20 bucks. So they'll service and support most of the popular aftermarket pans. All right, so getting into the rest of the transmission, we first have our overdrive roller clutch tucked away over here. This, no different than all one-way assembly, should always be replaced during an overhaul for any transmission you're building, at least any automatic transmission. And then our second upgrade we'll discuss, I was going to say first, but it's second, this is the first, is going to be this Sonic's billet low reverse aluminum piston. Now, for 96 and up 4L80Es that have this dome, it's kind of a second design dome style, these are known to crack around here where the pin passes through the casting. And so if you're doing anything even remotely performance or heavy duty and you're working on a 96 and up unit, I recommend you swap the factory servo piston out for a Sonic's billet aluminum version. The flat top style TH400s and 4L80Es 9195 isn't nearly as prone, but it's always a good upgrade to mitigate risk, especially if power levels get up there, 5, 6, 700 plus horsepower. All right, we are going to preserve the 1.2 accumulator, the CK Performance Master Recal Kit, which I guess is technically the first upgrade, so that makes this the second and this the third for anyone that's counting. The CK Performance Kit keeps the second accumulator active, but if you're going to run the Jake's Performance Recal Kit, which is the other one that's real popular on the market, he deletes the 1.2 accumulator in addition to the 2.3 and 3.4. So you're going to want to calibrate your 1.2 shift a little more conservatively, all other things equal, if you're running Jake's kit versus Chris's kit. Okay, Chris Krakonis at CK. All right, let's talk about the pump. So we have a brand new pump. So this is the original Stator Sport assembly, but it has been completely reworked. And then we have a brand new pump body. So I have a video that discusses lube mods for 4L80E, so I'll kind of show a little bit of that here. So this has a new bushing and all new machine surfaces with a new set of matching gears. And then what I did here is I drilled the drain back out to 1/4 of an inch. So again, anything heavy duty, high performance, it's recommended you do that for all 4L80Es. What was happening, especially on some of the earlier units, in the 90s, is excess fluid would pool in behind here, especially under high RPM. and it would not drain back efficiently enough so that you had too much fluid pressure and it would force the seal out. So this mitigates that risk, and 1/4 inch is sufficient. You don't need to go any wider than that. 4L60, 700 R4s, you can go up to 5/16 of an inch, but 1/4 inch is more than enough for 4L ADEs. I wouldn't recommend you go any wider than that. Okay, stator support and stator. So new bushings fitted. And then here is going to be our lube passage to the overdrive roller clutch assembly. Drill that out to 125 thousandths. And then if you are not installing the Sonex lube regulated pressure regulator valve, you're going to want to drill a 50 to 60 thousandths line to lube orifice right here. This opens up that line to lube circuit, so it's on all the time as opposed to only part of the time. So I don't want to get too far into the theory behind it. This will be like a 10-hour video, but suffice to say, the main takeaway here is that if you're running the factory pressure regulator valve, drill this hole in all builds. If you're not, if you're running the Sonex pressure regulator valve, do not drill it. The line to lube feature or full-time lube feature is designed into the Sonex valve. So we have a Sonex O-ring boost valve, and then the rest of the valve train's vac tested perfect, so no need to change anything out there. And then we have a freshly machined working surface here on the stator support. All right, so coast clutch drum continuing lube mods to the overdrive roller clutch. This is to be widened 125 thou, and then we have new bushings installed. Okay, so that brings us to the overdrive planetary carrier and the RevMax 300M billet steel input shaft. There's one key piece of information you need to know here if you've not used these shafts before, specifically from RevMax, and you plan on trying them out. And that is, you are going to need to file the bevel portions of the inboard facing splines on this carrier to allow your little snap ring to fit in the groove here, okay? So let me see if I can carefully take this out. So here are your splines, and then the splines I'm referring to on the carrier are these. This set of splines right in here. So what you're going to do is take a round file, just like this, and you're going to file just incrementally all the way around on the beveled portion until that shaft will pass through this carrier enough to allow you to seat and install the snap ring. Okay, so when I install the snap ring now, it fits like a glove perfectly. There is literally no play whatsoever between the shaft, the snap ring, the groove, and the carrier, unlike a factory shaft where you have anywhere from between 10 and 30 thou of play that you'll have to net out of your front end play calculation and measurement to derive your true front end play. So that's the one advantage of going with billet shafts. I mean, yes, there's a little bit of prep work you have to do, but they are machined to a much finer degree of tolerance relative to the factory counterpart shafts. All right, so that's the deal with that. 300M steel, it's good to go. Clutch module. So we're going to be running a combination of Alto Reds and Raybestos waffle style high energy clutches along with a factory spec steel module for late model 4L ADEs. Okay, you really don't need choline steels in these transmissions. I mean, you can install them if you want. There's no harm to it, but they're not necessary. So the coast clutch, the overdrive clutch, and the direct clutch are going to receive Alto Reds. The forward clutch and the intermediate clutch are going to receive the Raybestos high energies. All right, so I was trying to show you new bushings installed. Get this camera to focus. It just does not want to cooperate. All right, nothing particular done to the overdrive piston and piston housing. So the next upgrade we'll talk about is the forward clutch hub. So when power levels exceed about 500 or so, I'd recommend you swap from the factory piece to a billet steel equivalent. This is the Sonex ventilated heavy-duty billet rollerized forward clutch hub. So they make two versions of this hub. This one and then one that's about $10 cheaper, but does not have the roller and does not have the ventilation holes. I always get this one because, I mean, the price difference is essentially immaterial, and this is the better, the better product in my opinion. All right, we have new bonded pistons for your forward clutch and your coast clutch. And then for the forward drum, we've done a couple of enhancements. Okay, first you'll notice that we have a much wider bushing here in place of the factory spec bushing. This is a Omega Machine wide forward drum bushing. Okay, what this does is it acts as a much better stabilizing agent for your for your overdrive planet than does the factory bushing. Okay, so that fits in there nicely. And as you can see, it's very snug. Now, that wasn't spinning real easy because I forgot to actually put the bearing where it needs to go in this little pocket. But point is that if you're doing anything real high RPM, I recommend you purchase one of these bushings and install it. All right, the next thing that we have done is had the inner diameter where the input shaft goes, where sealing rings ride, we had that bored out and sleeved with a ductile iron insert. Okay, what this does is it mitigates the risk further of ring cut in this location by the sealing rings. Okay, so the sealing rings in question are going to be these two sealing rings right here, and they go on the inboard side, set of grooves I should say, on the input shaft. Okay, so that's a forward clutch drum, hub, and everything associated with it. Now let's talk about the direct clutch. So drum itself's factory, however, we did some enhancements. So for all high RPM applications, very high RPM, high horsepower, you want to drill a supplemental bleed hole between, I would say, 45 and 65 thousandths of an inch. This is 55 thousandths, so you can split it right down the middle and go 55. That'll work for pretty much any application you could think of other than maybe like, I don't know, 1500 horsepower and up. Then you probably want to go a little bigger. But what this does is it allows excess fluid that would otherwise pull in behind the piston to vent during a high RPM shifting between first and second gear. So when this drum is turning at tens of thousands of RPMs, that fluid is going to want to pull and it's going to want to push this piston forward into the clutch pack and either partially apply it, causing it to drag, or fully apply it and causing a major either tie up or stack shift when you're in either first or second gear, depending on what gear you're in when the event happens. So you want to pair that mod with high rate return springs. So these came as part of the master recal kit from CK Performance, and they will go into the piston. So this is obviously not a 4LADE late model piston. This is a TH400 piston that is sized such that you can fit 6 clutch discs and 6 factory spec flat steels with no cushion plate into the direct drum. So around the 750 to 800 horsepower levels when that becomes almost mandatory, and I would say it's definitely mandatory beyond 850 or so. So you have a little bit of wiggle room, but not much when you're in that area. So for me, because I'm a more conservative builder, more risk averse, I will do this anytime I'm purchasing a CK Performance Master Recal kit because it comes in the kit. And so I don't care if I'm building for 400, 600, 800 on up, I'm going to run a 6 clutch direct drum. Now I have a short video that gives you a few different options to get 6 clutches in there using factory components. So if you're curious about other avenues of approach, so to speak, you could check that video out. It's a short YouTube short video on my channel. All right, intermediate sprag, always buy the Borg Warner 34 element heavy duty regardless of what year or vintage of 4LADE you're working on. And for TH400s, you'll want to retro that with a 4LADE drum, or if you're working on a TH400 1964 to 1970, it should have the smooth inner race just like this one. And so, here I'm talking about the direct drum. So that will allow you to run the 4LADE sprag. You want to measure the overall diameter of that race to make sure it's still within spec if you're working on one of those early TH400 drums, or you're thinking about using it in conjunction with that sprag. All right, now let's talk about dual feeding the direct clutch, because that's what we're going to do here. So dual feeding is very simple. It's really a 4-step process. Okay, 3 steps in the case and then 1 in calibration. So step 1, you're going to leave the center seal and the drum off. There's a lip seal that normally goes here. You will leave that off or leave it out. Step 2 is going to be the second from the top sealing ring. You're going to leave that off. So you're going to put a sealing ring here, a sealing ring here, and a sealing ring here. Okay, so bottom, third, and first. Second position, you're going to leave off. All right, the third thing you're going to do is install a little 3/8 of an inch cut plug in the high reverse feed passage of the case when the transmission is fully assembled. So center support and all the guts are inside. Go ahead and install this in the high reverse feed location. Put a little red Loctite or RTV around the outer diameter just to be safe. And then punch it in with a drift until it makes contact with the center support and you're done. Okay, that's it as far as case mods for the internal dual feed. And then the last thing you're going to need to do is calibrate your high clutch shift so that because you have now access to the entirety, the underside of this piston as opposed to just the pocket, because in the factory, factory circuit, you only have the underside here come on or be, see fluid when you're in third gear. Okay. With the dual feed, the entire piston is available for apply fluid. So everything in this entire cavity is now being filled with apply fluid when you shift from second to third. So it takes a split second longer to fill, so you want to increase the size of your 2-3 shift feed orifice to about, I would say, 90 thousandths to start if you're running a factory setup with otherwise active 2-3, 3-4 accumulators. Okay, if you're blocking it off, then maybe you want to go a little more conservative and fine tune after a test drive. All right, so that's everything I wanted to talk about. The direct clutch, new coast band, new low reverse band. Let's talk about the intermediate clutch. So intermediate clutch is another area of sensitivity with high performance 4LEDs, TH400s. So we're going to run a Sonex heavy duty forged or billet backing plate for the intermediate clutch. Now, for those of you that are familiar with these transmissions, you know that I have the wrong plate here relative to the vintage of 4LED I'm working on. And that's because in my absent-mindedness, I ordered the wrong plate and I didn't even catch it until about, I want to say about 4 hours ago. So I have another one on rush order. It should be here Wednesday, and that'll allow me to finish the build. So anyway, we're going to use this as a stand-in and kind of show you what it looks like. I mean, basically it's made by Sonex in India, and it's billet steel, and there's two different versions for 4LEDs. Like I said, this is the early, and then the later versions are a little bit thinner because that's the, factory made the plate thinner because they changed the intermediate piston and added a cushion plate starting in 1996. So 96 is the change year. Anyway, like I said, this is a stand-in. The other one will be here soon. Okay, we already talked about the clutch module, high energy waffle style Rebestis. And then we have two different Chrysler A518 forward clutch snap rings. And that transmission, the 727s, A518, 618s, 46, 47, 48 REs, these are selective. So I got a 75 thou thick version and an 88 thou thick version. Okay, I'm going to end up with one of these two, and my target clearance for the intermediate clutch in this application is going to be between 70 and 100 thousandths of an inch. All right, the more RPM, the more horsepower, the more clearance you want to prevent clutch drag in first gear. So anywhere from 40 to 125 thousandths is the factory spec range. So you just need to, play within segments within that range based on the nature of the build and the intensity of the usage case. So for this, we're going to be on the higher end. If this was like 1,000 plus horsepower pro mod or something like that race, we'd go right up to 125 thousandths, an eighth of an inch. All right, we're going to pair that with high rate return springs and a heavy-duty spring retainer. Don't ever use the factory spring and retainer. That stamped sheet metal is real thin, and it will bend and contort under very high RPM and high torque. All right, new low roller clutch assembly, new bushings in the center support, and our output shaft. All right, we have a bearing back here. I already have it positioned how it would go. This rollarizes the rear of the case, so we'll use this in combination with a couple of shims, and we will be deleting the 3-tab steel selective washer and this Babbitt washer. Now, this Babbitt washer is not going to leave the transmission altogether. Okay, over here on your output carrier, you have a plastic 4-tab washer, but coincidentally, the Babbitt washer is of the exact same dimensions and fits right in there. So we're going to delete the plastic washer because it's plastic, and we're going to install the Babbitt washer instead. All right, so the last major upgrade I'll talk about is going to be our TCS billet steel 300M main shaft or intermediate shaft. And so I recommend this in combination with the input shaft to be billet. And all applications up to about 850 horsepower, maybe 900. Beyond that, you're going to want to start supplementing the drums, maybe do piston kits and a few other things. That's kind of beyond the scope of what we're doing here. Now, if he was going to be racing this thing at all times, then at that point we would have done some of those additional things, because again, you want to build the transmission to match both engine power output, vehicle profile, and intensity of usage. This is going to be predominantly a street-driven vehicle, some fun pulls here and there, but in my conversations with him, he has said he does not plan on taking it down the track, nor does he plan to install drag slicks. If he installed drag slicks, more billet parts would be needed. All right, so that's the inside of the case, all the components ready to go back together. I'll talk briefly about the case itself. So it's nice and painted and all prepped and ready to go, ready to take in all those parts. One thing I'll suggest as far as, mods, if you will, is take a block of wood, a 2x4 or a Durablock, and some 400 grit sandpaper and sand the worm tracks down. All right, do this before you clean the case off. Obviously, you don't want to have to clean the case twice. But doing this will knock down all the high spots, and you'll get rid of anything that could potentially cause a cross leak. It's the last thing you want, right? And then obviously check all your bores, make sure the sealing surfaces are good, check everything out inside the case, on the belly, the external, outside the case and everything. And then if you so desire, go ahead and mask everything off and give it a nice coat of paint of your favorite color. So here we went with gloss black. And the one thing I'll make mention of is you always want to prioritize preserving your ID stamps and tags. So this is the stamp. It indicates a 2003 model year unit. And you also have the ID tag here toward the aft section that indicates the same. So you don't want to paint over that stuff. And a lot of guys do. They don't take the time to mask it off. And I mean, I don't know. I guess people can do whatever they want. But I always want to ensure that that stuff is still accessible and visible. All right, guys, I know this was a really long video, but it hopefully gives you some insight into building 4L80Es for performance, and at the same time gives Tim a really good idea of exactly what we're doing with this transmission, since I'm not filming the whole build. So Tim, as always, thanks so much for the opportunity. I greatly appreciate it. And for everyone else watching, thanks for watching. If you have any questions, go ahead, put it in the comments, and I'll respond when I can. But until then, hope you guys have a great rest of your Monday and week, and we'll chat soon. Take care.